If sorting one deck takes a minute, then sorting 1,000 decks would take just 1,000 minutes, right?
Maybe, or it could take 1,000,000 minutes. It all depends on how your method scales, not just the clock. On the same laptop, one algorithm can feel like a turtle, while another feels like a rocket.
So, being fast depends on the recipe, not the machine?
Exactly. We're looking at how the work increases as the input size increases: more cards, more users, more data.
So, we step back and observe the overall trend, rather than focusing on every single second.
That growth rate is referred to as big O notation.
I've heard people mention big O of n. Is that what this refers to?
Imagine 3 graphs in a race: a steady turtle, a quick rabbit, and a wild rocket shooting straight up.
Each one represents a different type of runtime growth?
Linear time, big O of n, is like the turtle. If you double the input, it takes about twice as long, resulting in a straight line on the graph.
Slow but consistent as the data increases.
Quadratic time, big O of n squared, curves upwards. If you double the input, you do about 4 times the work.
It seems manageable for small inputs, but then it suddenly becomes challenging.
Exponential time, big O of 2 to the n, is the rocket. Just adding one more item means the time roughly doubles.
If you add 50 more, you might end up waiting longer than the lifetime of the universe.
On screen, we stack them: order n squared, and order 2 to the n, the same computer, yet completely different outcomes.
Now I understand. Big O really describes the shape of that growth curve.
Let's return to our decks of cards. The fast algorithm is the one whose graph remains steady even as the number of decks increases.
So, good scaling is better than just being a little faster today.
Big O allows us to compare algorithms, not hardware. A smart method can outperform a supercomputer using a clumsy one.
So, improving the code can be more important than upgrading the computer.
That's why we try to avoid algorithms that take exponential time whenever possible, especially as data sizes grow.
Otherwise, our applications slow down as soon as real users start using them.
However, some problems seem to only have slow solutions. That's the well-known P versus NP question, which has $1 million prize attached to it.
Alright, now I definitely care about Big O.
Please like, share, and subscribe.